Today we're going to be doing some work with the discriminant. Now the discriminant is just the part of the quadratic equation that is under the radical. So it's just the b squared minus 4ac. And based upon the sign of the discriminant, you can tell things about the solutions to the quadratic equation. So the discriminant can be either positive, it can be negative, or it can be zero. And each of these different scenarios produces different results. So let's first deal with the discriminant is negative. So far we haven't dealt with any situations where that occurred yet. The reason for that is because if the discriminant is negative, then you don't have any real solutions to the equation. But you do have two complex solutions or two imaginary solutions. So let me give you an example of what that would look like. So here is a quadratic equation. The first thing that you want to do when you're solving it with the quadratic formula is to identify the a, the b, and the c, which I'm sure you already know. So the a is 1, the b is negative 4, and the c is e. So if you want to go through the entire equation, you can. Let's do that for the first example. So we have, remember the quadratic equation is this. So now our whole quadratic equation would give us 4 plus or minus the square root of b squared, which would be 16, minus 4 times a times c all over 2. So now if you see under my radical, I have 16 minus 32. So that's the square root of negative 16. Because I can't take the square root of a negative number, this does not have real solutions. It has no real solutions. After this section, we're going to be going on to learning about what an imaginary solution is. But for right now, we're just going to say that there's no real solutions, but it does have two imaginary solutions. You'll see about that tomorrow. So now, if the discriminant is 0, this is a situation that we have dealt with. A lot of times, this one is easier. Then you only have one real solution. So let's do an example of that. So let's identify our a, our b, and our c just like before. Our a is 1. Our b is negative 10, and our c is 25. So now let's just deal with what's happening under the discriminant, because that's the part that's really going to determine what happens. So the discriminant is just b squared minus 4ac. That's the part that was under the square root. So now b squared would be 100 minus 4 times a times c. So now you see that equals 0. So, if I put this into the rest of the quadratic equation, I would see that I would get 10 plus or minus the square root of 0 over 2. Well, the square root of 0 is just 0. So I would have 10 plus or minus nothing over 25. Well, adding and subtracting nothing doesn't change it. So that's really just 10 over 25, which hopefully you reduce to 2/5. So there's no plus or minus anymore because I was just adding and subtracting nothing. That's why there's only one solution to this equation. So if the discriminant is positive, that means that you have two real solutions. This is mostly what we dealt with in the last unit, when we had two solutions to the answer, when we got a number under the positive number under the radical. So let's try an example of that. So let's once again identify our a, our b, and our c. And let's find the discriminant. So b squared is 25 minus 4 times a times c. So this is 25 minus 16, which is 9. So now, because this is a positive number, I know that I'm going to have two real solutions. If you want to find out what the solutions are, you have to do the rest of the quadratic equation, which would just be negative b, which would just be 5, plus or minus the square root of the number that we found as the discriminant. That number is that number, over 2 times a, which is 4. So the square root of 9 can be dealt with. That's 3. So 5 plus or minus 3 over 4. 5 plus 3 over 4 is 8 over 4, which is 2. 5 minus 3 over 4 is 2 over 4, which is a half. So here you can see that you have two real solutions. If the discriminant is positive, two things could really happen. It could be a perfect square or not. If it's a perfect square, then the square root can come out of the answer, and you don't have any more square root in there, so your roots will be rational. If you recall, rational just means that the number can be written as a fraction. So if you don't have a square root in your answer anymore, then your answers are rational. If you do have a square root, then they're irrational. If you look at the previous example, these are two real rational numbers, meaning that you could write them as a fraction. 2 as a fraction is just 2 over 1, and 1/2 is already a fraction. So sometimes, if you recall, we didn't have an answer like that. We would have the square root of 17 or something like that left in our answer. That means that your answers are irrational. So I thought I would make a little chart for you guys to make it easier to understand. So if you look, you have your, please write this down, you have your discriminant, and the three things could happen with your discriminant. It could be positive, it could be 0, or it could be negative. If it's positive, then two things could happen there. It could either be a perfect square or not a perfect square. If it's a perfect square, then you have two real rational solutions, meaning that your answers are going to be 3/4 and -1/2 or something like that. Or if your answer is not a perfect square, you're going to have two real but irrational solutions, meaning your answer will be 2 plus or minus the square root of 17 over 6, something that has a square root left in the answer. If your discriminant is 0, then there's only one thing that could happen. You'll just have one real solution. That solution will happen to be rational as well. So if your discriminant is 0, then you have one real rational solution. If your discriminant is negative, then you have two imaginary solutions, but you do not have any real solutions. So let's just do a few quick examples. So now that you understand the process, you don't have to go through solving the entire quadratic equation. All we're trying to do here, our only goal is to determine what the solutions will be like, not what they actually are. So for example, here we're just trying to find the discriminant. We're just doing b squared minus 4ac and figuring out what that tells us about our answers. So here, b squared will be 16 minus 4 times a times c. So 16 minus 8 is 8. Now this is a positive number, so we know that it will have two real solutions. Let's determine whether they're rational or irrational. Because 8 is not a perfect square, this means that we will have two real irrational solutions. Now let's try the next example. So here, b squared 16 minus 4 times a times c. So now I have 16 minus 16, that equals 0. Because my discriminant equals 0, that means I only have one real solution. It happens to be rational. So now let's try with this last example. I'm going to follow the same process. b squared 16. Oops, sorry about that. I already squared it. 16 minus 4 times a times c. So now I have 16 minus 8 times 3 is 24. This is negative 8. Because this is a negative number, I will have no real solutions. So when you're trying to determine the number of solutions, you don't have to actually find the solutions, you just have to say what the solutions will be like. So now I just wanted to take a moment to talk about what these graphs would look like. So if you have a situation where there's no real solutions, remember that a solution to a quadratic equation we often refer to as the roots of the quadratic equation or the zeros of the quadratic equation. That just means how many times will this graph hit the x-axis. So if you remember, y equals x squared is just the shape of a parabola. I know we haven't done this in a while, but remember what we did back to graphical transformations, how it was shifted up and down. We have this U shape. So if you have a U shape with no real solutions, the solution is a 0 where it hits the x-axis. That means that it's not going to hit the x-axis anywhere. So your U is either going to be above the x-axis and go upwards so that it doesn't hit it, or your U could be under the x-axis and be going downward so that it never hits the x-axis. That's what a solution is. If you have one real solution, that means that your parabola will only touch the x-axis once. The only way for that to happen is for the bottom or the top of your U to be sitting on the x-axis. So it could either be facing up and just touch it once at that one spot. That spot's the solution. Or it could be facing down. If it faces down, the same thing is true, though. It will only hit once. If you have two real solutions, that's the situation that we deal with most often. Then that just means that your parabola hits the x-axis in two places. So it could either be facing up, so it'll hit in this spot and in this spot. Each of those would be the solutions, or it would be facing downward. It would hit at this spot and this spot. But either way, it hits the x-axis in two places. Do not forget to answer the questions. Oh, I forgot. Our student of the day is Justin Mason because he did so well on his test. Good job.